In this video series, we're going to learn the integration technique, trigonometric substitutions. This technique can be helpful for integrating functions involving square root of a squared minus x squared, square root of a squared plus x squared, or square root of x squared minus a squared. We call the technique trig substitution because we substitute x with a trigonometric function. In this first video of our series, we're going to look at the first case where we have an integral involving square root of a squared minus x squared. Our approach is to make the following substitution. We'll substitute x equals a times sine of theta. We'll also be making use of the trig identity cosine squared of theta plus sine squared of theta equals 1. Let's look at an example. Let's look at the integral of square root of 9 minus x squared dx. We can think about this as the integral of square root of 3 squared minus x squared. So in this case, our a is 3. What we want to do here is to make a substitution x equals 3 times sine theta. Taking the derivative of both sides, we get dx is equal to 3 cosine theta d theta. So when we make our substitution, our integral becomes the integral of square root of 3 squared minus 3 sine theta squared, and then the dx gets replaced with 3 cosine theta d theta. So now our integral is in terms of thetas. So let's simplify this a little bit. This is the integral of square root of 3 squared minus 3 squared sine squared theta times 3 cosine theta d theta. If I factor out the 3 squared inside the square root, this gives me the integral of square root of 3 squared times 1 minus sine squared theta times 3 cosine theta d theta. What we'll do next is use our trig identity to rewrite 1 minus sine squared theta. I can rewrite this as the integral of square root of 3 squared times cosine squared theta times 3 cosine theta d theta. What we might observe now is that under the square root, each of those factors are squares. So we can simplify this. This becomes the integral of 3 cosine theta times another 3 cosine theta d theta, which we can rewrite as integral of 9 cosine squared of theta d theta. To compute this integral, I'm going to use another trig identity on cosine squared of theta. Use the double angle trig identity. So I rewrite this as the integral of 9 times 1/2 times 1 plus cosine 2 theta d theta. Distributing the 9/2, we get integral of 9/2 plus 9/2 cosine 2 theta d theta. The antiderivative here gives us 9/2 theta plus 9/4 sine of 2 theta plus c. Now all we have to do is write this back in terms of x. Now in the beginning, we said that x is equal to 3 sine theta. So we can solve for theta here. Divide both sides by 3, we get x over 3 is equal to sine theta. Then take the arc sine of both sides, we get that theta is equal to arc sine of x over 3. So our integral is 9/2 times arc sine of x over 3 plus 9/4 times sine of 2 times arc sine of x over 3 plus c. Note that there is a way to simplify sine of 2 arc sine of x over 3, but we won't go into that right now. Let's look at another example. Here we have the integral of 1 over 4 minus x squared raised to the power of 3/2, which we can think of as the integral of 1 over, in parentheses, square root of 2 squared minus x squared to the third power, dx. So we see here that the integral involves the square root of some number squared minus x squared. The approach to integrating this is to make a substitution. In this case, we're going to let x equals 2 times sine theta, so dx is 2 cosine theta d theta. When we make this substitution, we get the integral of 1 over square root of 2 squared minus 2 sine theta squared, all raised to the third power, times 2 cosine theta d theta. Let's try to simplify this expression. First, I'm going to square the 2 sine theta, which gives me 4 sine squared theta. And then we can factor a 4 from all of these terms, leaving me with the integral of 2 cosine theta in the numerator divided by square root of 4 times 1 minus sine squared theta. And then all of this is raised to the third power d theta. So then I'm going to use my trig identity and rewrite 1 minus sine squared theta as cosine squared theta. So our integral is 2 cosine theta divided by square root of 4 cosine squared theta raised to the third power d theta. Now everything under the square root here is a square, so I can simplify this as integral of 2 cosine theta divided by parentheses 2 cosine theta cubed d theta. After some cancellations, we get integral of 1 over 4 cosine squared theta d theta, which we can rewrite as integral of 1/4 secant squared theta d theta. And the antiderivative for secant squared is tangent. So this is 1/4 tangent of theta and then plus c. Now all that remains is to write this back in terms of x. In the beginning, we made the substitution x is equal to 2 sine theta. I can solve for theta here and get x over 2 is equal to sine theta, which means theta is equal to arc sine of x over 2. Substituting this back into our antiderivative, we have 1/4 tangent of arc sine of x over 2 plus c. Again, what we can do is simplify this expression. We have the tangent of arc sine of x over 2. Now let's start with the arc sine of x over 2. What I want to do is imagine a right triangle and think about arc sine of x over 2 as some angle in that right triangle. Now if we remember from trigonometry, sine of an angle is opposite over adjacent. So let's imagine a right triangle where one of the sides has length x and the hypotenuse has length 2. Now the sine of an angle is opposite over hypotenuse. So the arc sine of x over 2 would be referring to this angle right here. Now if I want the tangent of that angle, then what I need to do is take the opposite side and divide by the adjacent side. Using the Pythagorean theorem, we can find the length of this adjacent side. We get that this adjacent side has length square root of 4 minus x squared. Therefore, the tangent of arc sine of x over 2 is x divided by square root of 4 minus x squared. So our answer is 1/4 times x over square root of 4 minus x squared plus c. And that's my final answer. This is where I'll end this video. In our next video, we'll look at the case where the integral involves square root of a squared plus x squared.